right, here we are going to use substitution with word problems. So we are going to use the same order of operations that we need to for any simplifying. We're going to use PEMDAS, but before we do that, we have to actually set up the problem that's given by the word problem. So Ken Griffey Jr. teaches private baseball lessons. He charges every customer a one-time fee of $75 and an additional charge of $200 per lesson. How much would you owe if you took 9 lessons? So I'm trying to figure out how much I would owe. I'm going to label that as maybe my cost, or C. And that's going to equal a one-time fee, so it's just $75 one time, and then an additional charge plus $200 per lesson. That phrase is very important. Per lesson, or each lesson costs us $200. So I'm going to label that as L. 200 times the number of lessons that we take. So we're going to figure out how much we're going to owe for 9 lessons. So our cost is 75 plus 200 times 9. So C is 75. We're going to do that multiplication first. That's $1,800. Then we do our addition. So our final cost is $1,875. On number 2, Miss Hart has a store where she sells cookies. She sells the first cookie for $1.24, and every cookie after that for 78 cents. So our first cookie is $1.24 plus all the other cookies will be 78 cents each. So plus, I'm going to label that as 0.78 times C, where this is the number of cookies after the first one. So how much would you owe if you bought 48 cookies? So you might be thinking that you want to put in 48 there, but really we've already paid for one cookie here. That's the first one. We're really paying for the next 47 cookies here. So it's $1.24 plus 78 cents times 47. Another way you could write this, if you want to be fancy about it, you could write $1.24 plus 0.78 times C minus 1, where C is actually the number of cookies, and we're subtracting out 1 because we've already paid for one cookie here. You don't need to worry about that if you don't understand it. Really, we can just use kind of the logic of the next 47 as our replacement value. So $1.24 plus $36.66. And that gives us a final cost, of $37.90. All right, on these next two, we're given these equations right in the word problem. So we're told that the area of a trapezoid can be used, or can be found using that formula, 1/2 times h times b1 plus b2, where h is the height, b1 is the upper base, and b2 is the lower base. So there's some confusion sometimes thinking that's an exponent, but it's really just a label of the lower base, or just the bottom of the trapezoid. So that is b2, this is b1, and my height is going from the top to the bottom. That's that 4.5. So from here, I'm just going to plug these numbers in and follow order of operations. Anytime you substitute a number in, it should go in parentheses 4.5 in place of h. B1 is that 5.3. B2 is 10.9. Again, I'm not squaring this, it's just a label of that bottom. So I'm going to do 1/2 times 4.5 times, I'm going to simplify inside the parentheses first. That would give me 16.2. And then I'm going to multiply all 3 of these together. And that gives me a final area of 36.45. And since we're talking about area, our units are going to be squared. So our units here are inches. And when we're talking about area, we're literally talking about the number of little squares, little 1 by 1 squares, 1 by 1 inch squares that can fill that. So the units are squared. It's not implying that we're squaring the number. It's just a label for the units. The formula for the surface area of a cylinder is this. So the surface area equals pi times the radius squared plus 2 pi times the radius times the height. So we see some variables in there. First off, I'm just going to label pi as 3.14. That's actually not a variable, that's a constant number. But we do need to figure out what is h and r. So I'm just going to read that question. What's the surface area of the cylinder with a radius, where the radius of the cylinder is 2.4 and the height of the cylinder is 5.5. So really now I have all of my variables to substitute in, or my values for those variables to substitute in. I'm going to take those two numbers, and actually I'm going to take 3.14 and plug it in there too. And then I'm going to follow order of operations to simplify this. So I have multiplication and an exponent, then I have addition, and then I have a bunch of multiplication. So I'm going to do my exponent here first. That has to be my first step. Again, I'm following PEMDAS to make sure I do this in the right order. I don't really have anything to do inside the parentheses, but I do have an exponent that needs to happen before multiplication. So that leaves me with 3.14 times 5.76. Nothing else in the problem is going to change. I'm just going to rewrite that. So now I have multiplication, addition, and another multiplication. So I can work just left to right. Anytime you have multiplication and or division, if you have those two things, you just want to work straight across the problem. So I'm going to do this one first. So that will give me 18.0864. I'm going to round that to the hundredths place just because that's kind of where I started here. I'm going to keep that as the hundredths place, or 0.09 plus 2 times 3.14 times 2.4 times 5.5, and that's going to be my next step. I'm going to multiply all of that stuff together here. So that gives me 86.35. So my last step is just to add those two numbers together. That gives me a final answer of 104.44. And here we're talking about area again. It's surface area, but that's still area, so my inches, my units will be squared here. And that's my final answer.